Today on the bench a TM-451. This is a UHF radio and it comes in with a processor failure. So let's see what's going on here. And welcome to TRX Bench. Okay, so let's see what's really going on here. So our radio, the TM-451, is connected to our power supply, and let's fire it up. And okay, so that is not too bad. Okay, so we have static. So let me dial in here our 430-100 to our generator, and let's see. So 430, what is it, 100, okay. And yeah, let's switch on the output power. So we have now minus 80 dBm and our deviation is set to 2 kilohertz, and there is definitely no signal so far, so no receive. Yeah, let me show you what we have. So I've dialed in the frequency, and we have here our minus 80 dBm, which should be more than S9 level, and we have switched on here our deviation. So everything is fine, but we do not have nothing. So let's try what's going on transmit. So I'm just taking here the microphone and pushing the PTT. Nothing, so no output power at all. But yeah, let me go down here to our radio that you see what's going on. So yeah, I'm pushing here my PTT, as you can see, and you see that the radio is switching to on air, and you see here the indication for output power. And let me switch here between low, yeah, that is now low, and you see here the bars are now on 5. Let me go to full power, and you see it is here now, the bar is here on the over indication. So everything looks just fine, but we do not have output power regardless on which setting we put the radio. And there is no receive. So as I said, the generator is set to this frequency, and we really should have a strong signal, but you see nothing is working. But beside that, as we are able here to switch between yeah, frequencies, and we see that it is switching between TX and RX. So that is telling me that the processor looks on the first glance fine. So it does not really seems to be a problem with our processor. So not sure what the old man meant when he said that there is a processor fault, because that does not look like a processor fault. It rather more looks like an yeah, something I'm not totally sure, but I remember this is at the end it is a UHF radio, but there is a VHF receiver inside. And let me see. So with the function button here and the band button here, I can switch it, as you see, to VHF, and yeah, I can obviously easily change here the frequencies, so no problem whatsoever. So let me dial my generator to VHF and let's see if we have any receive on 145 point, what is it, 300 megahertz, and there we had a tone, but it is gone. So something is wrong here as well, and yeah, and it can't, of course, it can't transmit because it is a UHF transmitter only. But as you can see, we do not have receive either, so nothing. So there was a little noise, and I do not really know where it was coming from, but you see we do not have receive, and yeah, that now gives me an idea what's really going on. So I believe we have a kind of PLL problem. So I believe that local oscillator frequency for the mixer process is missing because we have no signal on UHF, both on transmit and receive, and beside that on 2 meter we do not have receive. So let's crack the radio open and let's see what's going on here. Okay, and here on the top side we only have 2 screws, and that is really easy. And yeah, let's see what we have. And of course we have here our speaker, and it is here, so this is a carrier here on the chassis, so we can take it out. And well, so what we have here, basically here is our power supply and all the different voltages, and this here is our amplifier module, and here is our filtering underneath, and this both cans here, massive metal cans, are our PLL and VCO circuit. So both is here in this massive metal can, and yeah, so we really should investigate first if the radio is not in unlock condition. So we want to find it in lock condition, of course. So that is the first step. But first, let's have a short view into our schematic to understand what I'm talking about here. Okay, and that might be the first where we should have a look into, and that is here our PLL VCO block. And what you can see here is our IC201, which is our main PLL and VCO block. And then here, this is our sub PLL VCO block, which is our IC203. And let me zoom in here a bit that you get an idea. So as it is always the same, we have here our ref oscillator. So this time it is a 12.8 megacycle crystal, which is finally reference. And well, you see here a low pass filter, and then here you see the input into our voltage controlled oscillator, and we have two parts, which is here the top side, our transmitter part, and down here, so that is our receive part of the VCO. And you see here our tuning voltage gets here into our receiver or transmitter, depending on where the switch is set to transmit or to receive. And then with the tuning voltage, the right frequency gets dialed in, and here we get our output, and this output is finally our local oscillator frequency. And well, it works as always a PLL VCO circuit is working. Very simple. So a free running voltage controlled oscillator, and the output of our VCO will get fed back here over this amplifier, buffer amplifier, and gets back here into our PLL IC. And in our PLL IC, this both frequencies, so our feedback from the output gets compared with our oscillator reference frequency. And of course we have divider here inside, so that the output, the reference frequency gets divided to a certain frequency, and of course our output frequency as well, so that inside our IC two the same frequencies gets compared. And if there is a phase error, then our PLL circuit will align this phase error with changing tuning voltage, which leads to a different output frequency, which will be at least exactly the same like the ref frequency. So that is what's going on here, and I believe that it has really something to do with our reference, with our PLL circuit, as we do not have both. We do not have transmit and we do not have receive. And additional to that, we have it here on our sub PLL VCO as well. I mean, that indicates somehow that there must be something wrong. And once again, if we look down here, so this is here our main PLL VCO block. So both is in this metal can, and this here is our sub PLL VCO block. So this is only for VHF receiver. Okay, and Kenwood was so kind to give us this information here, and you see, so these are the output pins of our VCO PLL block, and you see here LD is our output for lock or unlock condition, and you see if the radio is locked, then we would see a low signal here at our LD output, and if it is unlocked, then we would see, yeah, I believe 5 volt, because you see it is it will get 5 volt for its operation. So I believe that on the logic side here of our PLL circuit we will have then 5 volt if the radio is in unlock condition. Okay, and here we have a very nice PCB layout, and this is here top side or component side, and you see here is this both blocks, which this here is our main PLL VCO block, and you see here the pins 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and that means, seeing this, that means that it must be through-hole technique. So let me open here our lower side here of our housing, and let's see if we can find these pins. Alright, and again 2 screws, so very easy. So by the way, the radio is still connected to our generator, so if we would get here any change for any reason, we would directly hear it, because as I said, a strong signal is here connected to our radio. And alright, so let's see what we have here. And of course I have used my so that was component side, and now I'm on the foil side, so that means I have here, don't know if you can see it, but yeah, we have here through hole pins, and you can see them here and there for our main PLL VCO circuit, and then we have our sub PLL right. So yeah, it must be, where is it? No, it is here. So this here, these pins and these pins are our sub PLL. But we are first of all interested here in our main, and I'm interested in our lock or unlock output. Okay, and here we find what we are looking for. So our pin 7 is our LD terminal, and that will indicate if the radio is lock or unlock condition. So we expect a low to have the radio locked, and that is what we gonna check first. Okay, and that is now the foil side of our PCB board view, and yeah, what you can see here, so the right pin here is our pin 7, and we want to see here a low, and yeah, let's simply test that one. Okay, and yeah, I've put it down here that you can see both. So I have to test pin 7, which is up here. So it is the last pin on the right side here, and let's see what we have. And we are testing for 4.8 volt, which is approximately 5, but that is not so much important. And we have seen in our service manual that if it would be a lock condition, then we would see here a low. but what we see is a high, and that means that my assumption was right. So the radio is definitely out of lock, so it is unlock condition, and that means yes, we definitely have a problem with our VCO PLL circuit. So now we really need to go ahead and see what it is, but let me double check. I mean, we have seen here the 5 volt already, but our input voltage, so the supply voltage, the 5 volt, will be on pin 4. So let me double check, but I'm sure that our 5 volt will be present. So 1 2 3 4, 1 2 3 4. So this is pin 4, and you see 4.93 volt. So this is our 5 volt supply, and again here pin 7, which is our indicator telling us 4.8 volt, and you see the drop, so the voltage drop for caused by the components in between, and you see this is clearly a high condition, which means unlock. Okay, so let's think about how we could go ahead. And again, in cases like this, we refer to our service manual, and we go to the adjustment pages, and what we always find first, so let me enlarge it here a little bit, that you really can see it better. So we always have something called PLL lock voltage, and you see on UHF we have to dial in 435 megacycles, and which with a DMM we can test at test point 201 if there is the lock voltage present, which is on or should be on 435. It should be 4.7 volt plus minus 1 volt on, and on transmitter 3.7. So that would be a good next step to see if the lock voltage is simply present. And that is really nice. So you find here the test points, and our test point 201 is just down here, and here we should really read our 4.7 volt as indicated lock voltage for our PLL circuit. And of course, as it is mentioned in our service manual, we have to dial in our 435 megacycles, because only on that frequency we would see our 4.7 volt lock voltage, and we simply want to check if the 4.7 volt is present or not. Okay, and we do it in the same manner so that you really can see both. So I go down, of course we are on receive, and I go down here to our test point 201, and let's see what we have. And yeah, sure enough, we have 438 millivolt. So that is far away from our required 4.7 volt. So that means that our oscillator is really free running, because we simply do not have this lock voltage. And yeah, that makes me wonder if there is another voltage missing, because I mean we have on both PLL circuits the same indication on the VHF and the UHF, and I really can't believe that it is really an VCO or PLL problem, because we have two, and we have really the same problem on both. So that means it must be something what both circuits, both PLL circuits have in common, and that is most of the time it is a voltage. But just to see what's going on, let us see if we have a VCO voltage present or not. So that is interesting as well. Okay, and we do it again this way. First I've chosen here my scope, and I have looked here into my little table once again, and pin, let me double check, pin 9, so 7 was our unlock condition, then 8 and 9. So pin 9, which is this here, there we should have our VCO output frequency, which should be of course, because it is a local oscillator frequency, so that should be a sine. So let me see, and yeah, okay, so that is DC coupled, this signal. So you see I only have here, you see that it is jumping up because it is DC coupled, my scope. So let me couple it AC. Now it is AC coupled, and let's see what we have, and something is present here, and let me see what it is. So let me trigger it, and of course this is really a high signal, and it is, as you can see down here, don't know if you can see it, but my frequency counter is telling me 300, yeah, it is jumping between 303 and 312 megahertz, and of course this frequency is wide out of the range of our RIGOL, but we see that there is still a very strong signal present. It is still 74 millivolt, so very, very strong. And well, as I said, my scope is not able to really test for this high frequency. So this is a 50 megahertz scope, but I'm able to display, as you can see, 300 something megahertz. So this counter has given up, so this is counting wrong. It stops at 60 megahertz, but this here is more accurate, and it is telling me it is around 310 whatever megacycles. And yeah, let me prove it. I mean, we see we have a sine, so that means we have a free running VCO, so the VCO is working. I mean, we do not really know if the frequency is perfect, but it is somewhat working, which is very good sign. So let me double check the frequency. Okay, and for this test, let me take here our counter, because the counter is easily able to count up to over 1 giga cycle. So let me check once again the frequency here at the VCO output, which is, whoops, do not short it out down here, so which is 309.272 megacycles. So that means you've seen the reading on the scope. My 50 megahertz Rigol is really able to display 309 megahertz, so that is what it is. And yeah, what we do not know right now is if this frequency is good or is it bad. But if we need to know if our frequency is right or wrong, we can ask our service manual once again, and we find here our formula for our VCO, our frequency VCO, and the formula is simply telling us the dialed in frequency minus the IF frequency will finally lead us to the VCO frequency, which is needed to do the mixing process in the right way. And yeah, we have set our radio, because it is still here on our test setting, so it is set to 435 megacycles, right? And we have to set 40.05 minus, which leads to a IF frequency. So I have it down here, or we can do it once again. So 450 megahertz minus our IF frequency, which is 45.05, leads us to 400. Oh, did I do it right? Once again, our 435, sorry, 435 megahertz, 435 megahertz minus our IF, which is 45.05, means our IF should be 389.95 megacycle, and we have tested, yeah, once again, we have tested 309 megacycles versus 389.95, and you see, yeah, our VCO is obviously really free running, so missing 80 megacycles, so our output frequency is too low, and that simply means that the radio is really not able to receive. Now we know that the VCO is working. We know our radio is in unlock condition, so that our VCO frequency is free running, so it is definitely on the wrong frequency, and now we really need to know why is that the case. Okay, and as we discussed it earlier, I said I guess that there must be a second operating voltage which needs to get delivered to our VCO PLL circuit, and thus let's ask once again here our little table, and yeah, let me zoom in that you can better read it here. And what we can see so far here on pin 4, we tested for 5 volt, which was fine, because otherwise we wouldn't be able to see our lock voltage here, right? Because we see somewhat around 5 volt, which was telling us, okay, radio is unlock. And then we have now tested our VCO output, and we have seen that we had a free running oscillator, voltage controlled oscillator. It was free running, much too low in output frequency, and that is the reason why the mixing process doesn't work and we do not have receive. And additional to that, we see here there is our second voltage, which is delivered here to our PLL VCO module. And let's check for this voltage. I really wonder if this voltage is present, because once again we have the same problem on VHF, and I do not believe that this VCO PLL block is faulty, because I can't believe that both PLL blocks are faulty. So thus I believe something must be wrong here. And the second issue, what could be, is that our ref frequency is missing, because our crystal here on 12.8 megacycle is also responsible for both blocks. So if this here is not working, then of course the radio can't receive and would go into unlock condition, because reference is missing, right? Because therefore, first, to have a complete picture, this here is our 12.8 megacycle crystal. So let's simply see if here this crystal is working in our circuit. And I simply go down here to our let me go here to our screen, and let me go down here, and you see something is happening, but I need to put the attenuator in a little bit, and let's see if I'm now able to read it, and here it is. So what you see, a nice and clear sign, and you see the counter up there is telling us 12.799 whatever, so that means 12.8, and our software counter down in the left corner is telling us 12.8 megacycle. So that is telling me that our reference oscillator is working just fine. So let's go for our 10 volt, if our 10 volt is given. Okay, and on the table we have seen it should be present on pin 8. So pin 8 should be this one down here. So I'm really down there at point. So that is pin 8. Let me double check. Yeah, that is definitely pin 8. And on pin 8 there is definitely our 10 volt missing. So that is what I thought, that we really have a problem here with our supply voltage, and this is obviously right. So we only have 2.9 millivolt instead of 10 volt. So okay, let's see where our 10 volt should come from. Okay, so therefore let's have a look here into our block diagram. So I have to rotate it a little bit, and yeah, let me zoom in. Okay, so let me zoom into our VCO PLL blocks, and yeah, we was always testing on the main PLL VCO block, which is this here, and of course here's our sub block, and yeah, somewhere here we should find our 5 volt, and yeah, I can already see it. Here is our 5 volt input. Here is, by the way, our 12.8 megacycle reference, which is connected to both circuits, sub and main, as you can see, right? And yeah, where is our 10 volt input? Can't see it. I can't see it. Do you already see it? Ah, alright, here it is. So here is our V10, which is supplying both, and we have seen here, tested at our main, it is not present, so that means we need to find where it comes from. And maybe we move here to our input. So this here are our wires, our supply wires. Here's our fuse, 13.8 volt input, and what we can see, yeah, here we have a transistor which is obviously switched by the processor. So processor seems to set here a switching signal to let our voltage here through to our voltage regulators. And you see here our IC204. Our IC204 is our V10. So this is here a voltage regulator, a 10 volt voltage regulator. And what we need to find, where is our 204 and what is at its output. We need to see 10 volt. Okay, so now we have to go to our diagram, to our here it was, I believe. Yeah, so this is our circuit diagram, and we do exactly the same. We zoom in, and what we can see, so that is always very easy to find. So here is our input. So our leads here, and then our connector, and here we have our 13.8 volt, and we simply follow here our line. And yeah, what we can see so far here is our Q107, of course, and here our switching transistor. Yeah, so this is a PNP type, this is a NPN type, so that means if there is a positive voltage coming from our microprocessor, this transistor will switch through, so that we have ground here at our base, which means that our PNP type will switch through as well, and then we will have here 13.7 volt, and we have here 8 volt regulator, and this is here obviously, yeah, here a 5 volt regulator. But where is our 10 volt regulator? So it can't be behind our 5, it can't be behind our 8, So it must be somewhere, because we have seen here our Q107 is in front of the 10 volt regulator, so we need to follow this line here, and yeah, here we are. So this here is our 10 volt regulator, and you see at the input of our IC204, by the way, we should read 13.7 volt, and then at the output we should read here our 9.9, so our 10 volt output. And you see here is a 10 volt ripple filter, a very good ripple filter, and that proves that this has something to do with our VCO circuit, because of course for VCO we should have a low noise regulator type, and of course we should really have a good ripple filter, and that is given. So this is a LA5010, so which is a special IC, and then directly we have our ripple filter. That definitely means it has something to do with our VCO circuit. Okay, so let's search here our IC204 on our PCB board diagram. By the way, of course, I have seen that here we have test point 101, so that means we are looking for test point 101 if we really have our 13.7 volt here at test point 101, and then of course we want to check if it is present here directly at our IC, and then we can of course go ahead. Yeah, and this is again our foil side of our PCB board diagram, and yeah, I have already looked around a little bit because sometimes it is difficult to find, because it hides behind always anything. But anyways, here we have our IC204, so that is our 10 volt regulator, and you can see here pin 7, which is our input, and let's see our test point 101. So you find it here. So here is our test point 101, and yeah, let's simply test what we can find down there. Yeah, and looking here onto the board, so there we have our test point 101, and down here this is our IC 204, right? And here are our 3 little caps. That means this is pin 7, where we should have our input, so our 13.7 volt. But no, let's go down and let's probe what's going on here. Okay, and first of all, let me go down here to test point 101, and we expect our 13.7 volt, and here we are. So 13.6 volt is given at our test point 101. That means we go ahead to our IC 101, not 101, sorry, our IC, what was it, 204, which is here our IC. You remember, it is our IC down there, so that is our IC, and here at pin 7 we should be able to read our input voltage, and that is what we want to see. So let me go down here to, can you see both? I believe yes. Okay, so let me go down here to pin 7. Is that pin 7? Aha, okay. Okay, so our input voltage is missing. Okay, that is odd, because on the schematic we have seen there is nothing in between, so it is only a junction, or if you like, a piece of wire. And yeah, we can clearly see that our 13.7 volt is not present. Back to test point 101, and yeah, it is still there, and it should be down here for sure, but it is not. So what does that mean? Okay, so let me take the radio here from the power supply, so it is off. Okay, and let me switch here my meter to continuity. Okay, so now of course you hear the beep, and I'm interested if we have at pin 7 to ground maybe a short or so, just in case. No, we have 1.6 kilo ohm, which is fine, and here from test point 101 it is 1.2 kilo ohm, so that looks good. But now I'm interested what is with continuity. If I test between input of our IC, so pin 7 to our test point 101, because as I said, we should really have continuity between test point 101 and input. So let me check, and no, so it displays 1.9 kilo ohm, which is not what we need to have. So once again we should see, and it is indicating open in between, but this should be fully continuity, so low resistance between test point 101 and of course our input. Okay, so again, let's go back here to our schematic, and once again what we have done. So look here. So here is our IC, and here are our 3 little caps, and here we should read our 13.7 volt. And if we follow along here, we see from test point 101, where we definitely have our 13.7 volt, we should easily read here at the input of IC 204 pin 7, we should easily read our 13.7 volt, but we don't. So that makes me believe that there is an interruption between test point here 101 and our input of our IC, and that is obviously a connection in one of the layers inside our PCB. I mean, we have tested here for continuity between this point and this point, and we didn't get continuity information, so that means it must be interrupted. And the question is why it is interrupted. Have we, or was there a high current draw for any reason, I really don't know, but that is a bit weird. So I think, because we do not really know if there was a short, or maybe it was only a temporarily short, so we really can't be sure. So therefore I would go ahead and inject here our voltage, but I do not like to put directly 13.7 volt to this pin. I would rather more like to crank the voltage up and observe the drone power consumption to be sure that there is not a short or an excessive power consumption, and if I increase it by an external power supply, I can easily interrupt this voltage supply if I see there is an excessive power consumption. Okay, and therefore I have now prepared here my power supply, and yeah, as you can see, I start off at 1.8 volt, and then I of course can increase it, and I've set the maximum amps to 100 milliamps, so it can't increase this amount of current. So it is for, or in any way it is limited, and that is what I want to. And now I just try, I mean, alright, the radio is back on, alright, and I've set the frequency back to our generator frequency, so radio is still connected to our generator at 430.100 megacycles, and we are injecting with minus 80 dBm, which is at least a strong signal. It is over S9, and I've set the deviation to 2 kilohertz, so we should hear our 1 kilohertz audio tone if it is receiving. And yeah, therefore let me see if we maybe can get it. I don't know, this is a little bit tricky because I try. I hope I will not short out here anything around the camera. Is always a pain, really it is. So let me see. That is obviously the best I can do, that you can see both. So again, I gonna inject here my voltage directly to the input, and we know we should have 13.7 volt, what we don't have anyways. First of all, of course, I have to switch on my power supply, which is switched on now, and you see I already draw 1 milliamp, which is really nothing. And now let me here increase my voltage, and once again, and I will check here my drone amps. So this is still looking very nice. So 7 volt, and let me double check. Oh, once again, so volume was set too low, so I have only set here my volume up a little bit, and yeah, let me put squelch to 0, so that we can hear the static. Okay, and now once again let me increase it, and you may already hear static is changing a bit. And with 6.8 volt already we have signal. We have signal and we hear our tone. So let me go here, let me go to 10 volt. So we are drawing 5 milliamps. So that is fine, no problem. And you hear, and let me see if you can see it. Yeah, I take it away and you see we are losing signal. Let me simply do it this way. Once again, our supply voltage back here to our input, and you see really a strong signal. I mean, that is clear, with minus 80 dBm. And again I put it away and we are losing signal, so that means that really means that there is an interruption on the PCB. So for any reason our the trace inside our board is for any reason interrupted, and what you can see down here, there you can see a little hole, and this is where our trace goes down here into the PCB in a different layer, and it should go or come here from our test point 101, but it will not. So if I go down here to the caps, you simply hear that the radio is working. So that means, repair is done, or minimum we know what we have to do, and that is very, very easy. So I have to put a new wire here from the input here of our IC to our test point 101. So I simply run a wire over here to the input, and then the radio will work again. So no problem. Okay, and you see and hear the radio working. So everything is working just fine. So let me turn it down a little bit, and what have we done? As we described it before, I simply have run here wire from our test point 101 to the input of our IC, and that means this wire is now bridging the lost connection between these both pins or whatever, and the radio is back working without a problem. Okay, and of course I will now fix here the wire that it can't go off or so, but finally our repair is done, and I will stop the video here. I hope you all enjoyed it a little bit, and you really was able to follow the description, And yeah, if you like it, please give me a big thumb up, because that really helps. And catch you next time. Bye.